night for the first time I got a chance to sit down to get a couple beers with the wife. But that's the name of the game. Dave was talking about the Saturn. I launched 5 of the Saturns in the Apollo program, and that is some event. It takes, you see the model out here, the 5 engines they've got down at the base consume 3 tons of propellant each per second. Okay, the turbo pumps that are moving that propellant are 55,000 horsepower pumps. So they're moving that fuel through that entire column from the tanks down into the engines. And to me, watching a Saturn launch is a visceral event. During launch, the flight director had responsibility for any abort related to spacecraft systems. The launch director had the responsibility for an abort if he saw a collision with any part of the launch tower. So basically, it was a dual responsibility during about the first 10 seconds of powered flight. Once the Saturn cleared the tower, the launch tower, then it was the flight director's responsibility for the rest of the mission. In mission control, we split the responsibility for abort in 3 pieces. The flight director had the responsibility for all the systems requirements, any abort from a system standpoint. The trajectory officer made the calls once we had decided to abort, but it wasn't time critical, so that we would abort and place the spacecraft down in one of our landing areas where we have recovery forces. The booster engineer had the responsibility for the abort in case the engines went hard over, because and the rocket would start tumbling during flight because we had tension ties that attached the spacecraft to the upper stage of the rocket. And basically it was about a 20-second decision time once this thing started in tumbling motion before you'd have structural failure. So the booster engineer had responsibility for abort, the trajectory officer had responsibility, and I had it. So that's what it was all about. It took 10 seconds to clear that tower, and you got pretty good at saying a lot of prayers in those first 10 seconds, because once you got past that tower, the crew was on the way. A few words about the lunar landing. I was the flight director for the first lunar landing. Had a team of between 15 and 21 controllers. Average age was 26 in mission control. I was the oldest guy in mission control that day. And as the time, you do a maneuver in the backside of the moon, which actually starts slowing down the lunar module so that the moon's gravity is now pulling it towards the surface. And as it approaches 50,000 foot altitude, we then make a go-no-go whether we want to continue this descent, again start the lunar module engine, which will further slow it down and allow gravity to bring it down to the surface. The day that we started this process, we had, it was just like our worst training day. As soon as the spacecraft cracked the hill, we had all kinds of communications problems. It was so bad we couldn't communicate with the crew of the lunar module, so we had to relay instructions via Mike Collins. About that time, my trajectory officer tells me that we're halfway to our abort limit radio velocity, and the word abort was not used casually in mission control during any mission, particularly when going down to the surface of the moon. We had, as I said, electrical problems, communication problems continued. We continued the descent. And as we're getting roughly around about 30,000 feet, we start looking for radar because the ground is updated, told the computer on board the altitude above the moon, but that could be an error up to about 5,000 feet. And that is not good enough to land on the moon. So basically we had to get radar data, and about that time we started seeing a series of computer program alarms. The computer program alarms are 2 types. There's what we call bailouts, where basically the computer would move into a cycle where it would only do the priority things. If you got a lot of bailout alarms, you'd go to voodoo. Computer goes to halt. Basically, you've aborted the mission. You have to relaunch and go back and re-rendezvous with the command module. We now know we're going to be landing downrange several miles, so the crew is going to have to pick over a landing spot, work around craters, etc. And now we're starting to suck air in mission control because we are not able to measure a fuel quantity at the bottom of the tank. It's sort of like driving your car on empty, where basically the gauge gets down there and we know we got about 2 minutes of fuel remaining at about a 30% power level. So now we're counting the seconds of fuel remaining once we pass time we landed at the moon, we had less than 17 seconds of fuel remaining, and we were in the process of getting ready and coming down to a very difficult, very risky land abort position. But the day we hit the moon, we did it. We got the crew down there, and it was interesting. Everybody's celebrating. My team's going to work because we now have to make a series of stay-no-stay decisions over the next 2 hours. So we did not begin our celebration until we finished our shift 2 hours later. It's up to you. I've got ready to launch. How are we in the launch prep? Okay, good to go.
Achieving a goal before this decade is out of landing a man on the moon and returning him safely to the earth. Most human space projects in this period will be more impressive for mankind or more important for the long-range exploration of space. None is big enough or expected to accomplish. That's why some say the moon. Why choose this as our goal? So they may well ask, why climb the highest mountain? Why 35 years ago, why the land? Why is right place Texas? We choose to go to the moon. We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard. Because that's all. We're driven to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are willing to postpone, and one we intend to win.
For all the people back on Earth, the crew of Apollo 8 has a message that we would like to send to you. In the beginning, God created the heaven and the earth. And from the crew of Apollo 8, good night, a Merry Christmas, and God bless all of you on this good earth.
On back light. Okay, engine stop.
We copy you down, Eagle.
Listen, tranquility base here. The Eagle has landed.
Rocket point, Tranquility, we copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot. Now they'll step off the limb now. That's one small step for man. One giant leap for mankind.
A 60-second mark on the Apollo 11 mission. T-minus 60 seconds and counting. We passed T-minus 60. 55 seconds and counting. Neil Armstrong just reported back. It's been a real smooth countdown. We passed the 50-second mark. Power transfer is complete. We're on internal power with the launch vehicle at this time. 40 seconds away from the Apollo 11 liftoff. All the second stage tanks now pressurized. 35 seconds and counting. We are still go with Apollo 11. 30 seconds and counting. Astronauts report it feels good. T-minus 25 seconds. 20 seconds and counting. T-minus 16 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5.